Hello everyone. So my name's Layan, and inshallah today we're going to be covering two lectures. One is the hormonal regulation of the menstrual cycle, and the second one being the uterine and ovarian cycles, or estrogen progesterone. Now, the way I'm going to cover this, I'm not going to do the first lecture first and the second lecture second. I'm just going to blend it all into one whole process because I feel like it makes more sense that way. Inshallah, we're going to cover everything more smoothly. So for the repro part of in the repro, it's honestly one of the easiest exams you can get, whether it's the MCQ part or the OSCE part. It's very easy as you genuinely understand, because if you go into the exam just having memorized the female cycle, you're not gonna know what's happening, you know? So this is very important to really understand the overall process, especially with Dr. AJ's slides. His slides can be very, very compacted and dense, and a lot of it is not needed for you, you know, like there's a lot of information that you're not really going to be tested on. So inshallah, I tried my absolute best to just keep in the high yield points and just simplified main concepts that you are going to be tested on. So let's start. What even is a menstrual cycle? Now, I'm asking this because I know so many people that don't even know what a cycle is. And from experience, when I was a secondary last year, I asked so many people, especially the males, what do you think is a menstrual cycle? And honestly, I'm very certain at this point that at least 50% of you watching don't know what a menstrual cycle is. So if I just hit you with the biology behind the menstrual cycle, you're gonna panic, I know. So what we're gonna do is we're gonna try to simplify the concept of a menstrual cycle and then add on it detail as we go. So slowly and slowly with each slide, we're gonna build on the detail, but we're gonna start with a very simple basic concept of what a menstrual cycle is, what the purpose of a menstrual cycle is. Because once you have a firm foundation of the purpose and the function of menstrual cycle, it's gonna be way easier to connect the roles of the hormones and the changes in the ovaries, the changes in the uterus. So with that being said, this is a brief overview of what a menstrual cycle is. So basically, the purpose of a menstrual cycle is for its preparation for embryo implantation. In other words, one second. Okay. In other words, basically, we're trying to prepare the uterus for fertilization because it's expecting a sperm. Okay, so every month the female body goes through changes in order to prepare for embryo implantation. It's preparing for fertilization. So how does that start? At puberty, the rate at which the gonadotropin releasing hormones are released changes. What does that mean? In other words, before puberty, the rate at which the GnRH is released is very steady. Okay, so we have a steady levels of GnRH. After puberty, the release of GnRH becomes pulsatile. So for example, every 2 hours, you'll have a spike of GnRH. Then it goes down. Then after 3 hours, a spike. Then every 2 hours, a spike. Every 2 hours, a spike. So this is the main difference that pushes the body into puberty mode, or okay, we hit puberty. This is how the body knows. Okay, so before puberty, it's a very steady pulsatile release of GnRH by the hypothalamus. Once you hit puberty, the release of this GnRH becomes pulsatile. The rate of the pulses is different for each hormone. We're going to discuss that later, don't worry. But just for a general concept, before puberty, it's non-pulsatile. After puberty or at puberty, the release of GnRH from the hypothalamus becomes pulsatile. This pulsatile release kickstarts the body into puberty. Now, what happens is, basically, like we said, the GnRH is released from the hypothalamus in pulsatile fashion. This is gonna activate or stimulate the anterior pituitary gland to release FSH and LH, okay, or the follicle stimulating hormone and luteinizing hormones. These hormones are going to act on the ovary mainly. The ovary is going to synthesize estrogen and progesterone. The estrogen and progesterone are the main hormones that are going to affect the uterus, the fluctuations and everything like that. So this is the main idea of a menstrual cycle. Okay, so if we go back here, basically the change or pulsatile fashion of GnRH is going to lead to the release of FSH and LH from the pituitary gland. This is going to cause the ovaries to secrete estrogen and progesterone. This estrogen and progesterone causes changes to the oocytes, which are the eggs, and the uterus simultaneously. Okay, now why are we doing all of this? All of this, again, is to prepare for embryo implantation. So the wall of the uterus here thickens because it's trying to implant an embryo. The egg here ovulates or leaves the ovary to come here and search for a sperm. So all of these processes that are happening are like a kickstart for expecting an embryo. Okay, so what if embryo implantation does not happen, or there is no sperm, there is no fertilization? So when that fails, the endometrial lining sheds. Okay, so this thickening of the endometrium, it was thickening because it's trying to expect an embryo. There is no embryo. So what happens to all of this thickened endometrial lining? It just sheds. Okay, so this is the bleeding that we see, or in other words, menstruation or menses. Then the cycle repeats. So this in general, I know this might sound detailed, but trust me, this is very general compared to what actually happens. So this in general is what happens in a menstrual cycle, okay? And one thing to keep in mind is that the pulsatile secretion of GnRH every 60 to 90 minutes is what promotes LH secretion, and every 120 minutes is what promotes FSH secretion. Okay, so just keep that in mind. So the rate at which GnRH is released can or does influence which hormone is being stimulated. Okay, this kickstarts the cycle. Estrogen and progesterone are produced. And another main concept of the menstrual cycle is feedback regulation. Now, the release of estrogen and progesterone from the ovaries are going to negatively, or they're going to induce negative feedback on the anterior pituitary. So as the ovary is producing estrogen and progesterone, that's going to tell the anterior pituitary, okay, let's stop producing FSH and LH because we have enough estrogen and progesterone. Or not really stop, just slow down and reduce. Okay, so this is like the feedback cycle that happens. You have FSH and LH, they stimulate production of estrogen and progesterone. Estrogen and progesterone induce negative feedback on FSH and LH, and so on. So this is the main concept of a menstrual cycle. Now, this graph is super important. We're gonna build on this graph throughout the entire lecture. So basically, we're gonna dissect this graph one by one. So remember when we said that the menstrual cycle is changes happening to the ovaries and the uterus simultaneously, okay, under the effect of the hormones. So if you look here, this part describes the ovarian cycle, or changes that are happening to the ovaries, to the eggs, to the follicles. This over here describes changes happening to the uterus, or the uterine cycle. And these are the hormone fluctuations that are resulting in all of these actions happening, okay? So the way we're gonna go about this is we're gonna understand the ovarian cycle first, understand why we have these fluctuations in hormones. Then as a result, how do these hormones affect the endometrial or uterine walls? Okay, so we're gonna dissect this one by one and then piece all of the puzzles together to fully grasp the menstrual cycle, because this graph is very, very important. You're gonna see many questions on it and it's not gonna come labeled. So you need to have a really firm understanding of what is happening at the same time. Like what is happening in the eggs that is happening at the same time in the uterus. What hormone is high in this stage and in that stage. So you need to have a firm grip on this graph, and inshallah, this is the purpose of today's lecture. So let's start. So the ovarian cycle, as we said, we're gonna dissect. So we're gonna start here first in one, which is understanding the ovarian cycle. Now, in the ovaries, you have the eggs, right? Or the oocytes. These oocytes, they're not just present and floating around within the ovaries. No, each oocyte is surrounded in a follicle. A follicle is basically this entire structure, okay? But basically what happens is you have an oocyte inside and it's surrounded by cells or follicular cells. This entire structure is called a follicle. This is what keeps the oocyte nourished and in one place, okay? So within the ovarian cycle, we're gonna discuss how does the follicle develop and how do the oocytes develop, okay? So this is the first step. Now, one thing to keep in mind is that within the ovarian cycle, we have a follicular phase and a luteal phase, okay? Follicular phase is everything that happens before ovulation or pre-ovulatory. Luteal phase is everything that happens after ovulation or post-ovulatory. Ovulation is the release of the egg from the follicle. Don't worry, we're going to understand all of this, inshallah, one by one. So, again, we're talking about the ovarian cycle, okay? We're going to just discuss the changes or development. As you can see, there are many changes happening to the follicle and the egg and everything, okay? This ovarian cycle is divided into follicular phase, ovulation, and luteal phase, okay? So this is basically what's mentioned here. The takeaway point that I need you to remember, especially for exams, you're definitely going to get a question on this. You need to remember that the luteal phase is always 14 days. It does not change. Now, the overall duration of a cycle is usually around 28 days, but it can go to 35 days. It can be 30 days. It can be 32 days. What's the change that, which phase is the one that's changing the time? It's the follicular phase, okay? But the luteal phase stays 14 days. So you're gonna get many questions on the exams, or maybe one question, but it always comes. For example, they'll tell you a woman, her cycle is 32 days, okay? And she ovulated on day 16, okay? How long is the follicular phase, or how long is that, or how long is this, okay? So you need to know that the luteal phase is always 14 days. I have a question for this in the end, and we'll solve it together because I forgot exactly the numbers or what happens when. We'll solve it today later, don't worry. But this concept you need to always keep in mind is that the luteal phase is always 14 days. Any changes in the duration of the cycle are because of changes in the length of the follicular phase. Okay, so just making sure that's clear. So let's start. So why is this here? I don't know. Anyways, so first of all, let's start with how does the oocyte or the egg develop? Now, the egg development is called oogenesis. Now, this should be familiar from foundation, but just a quick recap because it's very important. We are basically born with primary oocytes. So follow with me over here. We're born at birth. So we're born at birth. At birth, we have primary oocytes, okay? These primary oocytes are arrested at prophase 1 of meiosis because, the oocytes need to go through meiosis 1 and then meiosis 2 to fully grow, or mature. So basically, we're born with a bunch of primary oocytes that are all arrested at prophase 1 of meiosis 1, okay? So what takes this primary oocyte out of its prophase arrest? It's basically the LH surge of puberty. What does this mean? During puberty, remember, when we hit puberty, we start going through the menstrual cycle. Within the menstrual cycle, there's a period of time or a hormonal change called the LH surge. Okay, we're going to discuss this also in detail. Don't worry, I'm just slowly trying to build up the concepts. So this LH surge happens right before ovulation. Okay, the LH surge is what allows the oocyte to leave its arrest from prophase and enter meiosis 2. Okay, so again, we are born with primary oocytes. These primary oocytes are all arrested at prophase 1. When does this arrest, when is this arrest removed? During the LH surge of puberty, the primary oocytes become secondary oocytes because they undergo meiosis 2. Okay, but even then, they become arrested at metaphase now. Okay, so again, what happens at birth? We have primary oocytes. They're arrested at meiosis 1, specifically the prophase. Then we have an LH surge that's going to remove the arrest and it's going to allow the primary oocyte to enter the second meiosis. But again, it gets arrested at metaphase now. Okay, a way to remember this is PM. Okay, so in meiosis 1, it's stuck in prophase, and meiosis 2, it's stuck in metaphase. Okay, so now it's stuck again, even in puberty, the oocyte remains stuck in metaphase of meiosis 2. What removes this final arrest? It's fertilization. Okay, so if fertilization does not occur, the secondary oocyte remains stuck in metaphase of meiosis 2. Okay, this is the egg that gets ovulated or that leaves the ovary. So this is basically a summary of what we talked about. It's what the egg goes through. So again, when we're born or at birth, we have primary oocytes, okay? But they start at meiosis 1. Before ovulation or before puberty, in other words, meiosis 1 is arrested in prophase 1. During ovulation, or in other words, when we hit puberty and we undergo the LH surge, meiosis 1 continues and a secondary oocyte forms. But this secondary oocyte is arrested again in meiosis 2 metaphase 2. Okay? So this secondary oocyte that's arrested in meiosis 2 metaphase 2 is going to get ovulated. So it's going to leave the ovary. If it finds a sperm to fertilize with, then this arrest is gone and basically it resumes and it forms like a mature ovum. If it does not find a sperm to fertilize with, then it just degenerates. Okay, so basically this is what the egg goes through. We're born with the oocytes, primary oocytes arrested at prophase 1 of meiosis 1. Then with the LH surge or ovulation, it becomes in meiosis 2, metaphase 2. Then it gets ovulated. If it does not find a sperm, it degenerates. If it does find a sperm, the arrest is removed and it forms a mature ovum. Okay, so does anyone have any question regarding the oogenesis part? I'm just going to keep going, but please feel free to interrupt me at any point. I don't mind. Okay, so now we have the folliculogenesis. I don't know why this is kind of stuck. When I send the PPT in the end, inshallah, it won't be like this. Okay, anyways. So, as we mentioned, the oocyte in the ovary, it's not just floating around. It's actually held in a structure called a follicle. So this over here is the oocyte inside, okay, so this part. And it's surrounded by these follicular cells, if you can see. Okay, now these follicular cells are surrounding the primary oocyte. We call this the primordial follicle. Okay, so this is what we have at birth. Okay, so when we're born, we have a bunch of primary oocytes, as we mentioned, arrested at prophase 1. Okay, but they're not just floating around everywhere. They're contained within the primordial follicle. Okay, so this over here is called the primordial follicle. Now, how does this follicle develop? Basically, this is a mistake, by the way, it's not primary. It's secondary, okay. So, what happens is, these squamous follicular cells, they become cuboidal. You can see the difference between this shape and this shape. So they go from squamous follicular cells to cuboidal follicular cells, okay? When they do that, they're called granulosa cells, okay? These are like the matured or developed granulosa cells, okay? So all of these cells surrounding the oocyte are called granulosa cells, okay? So the change of the cells from squamous to cuboidal is the first sign of follicular growth, okay? So the presence of cuboidal granulosa cells is the first sign of follicular growth. When we see cuboidal cells, we can call this a primary follicle. When you see squamous cells, it's called a primordial follicle, okay? Now, after it has formed this cuboidal layer, it starts to proliferate and proliferate and proliferate, forming multi-layer granulosa cells. When it becomes multi-layered, over as you can see here, when it becomes multi-layered, we can call it a secondary follicle. So again, we go from primordial follicle, which is the one we're born with, and keep in mind, throughout this, the oocyte inside is still a primary oocyte, nothing changed. Okay, it's still primary, it's still arrested at prophase 1, meiosis 1, okay? It's still arrested, nothing is changing. We're just describing the development of the follicle as a whole, okay? So, when it goes to cuboidal, a single layer of cuboidal cells means it's a primary follicle. Multi-layered granulosa cells or cuboidal cells are the secondary follicle, okay? Now, this growth happens in puberty. It doesn't happen necessarily in response to the LH surge. No, it does not. It's not like the oocyte. It just happens, It starts to develop as soon as we hit puberty. The follicles start to mature and develop. Okay, it's not in response to a certain point of the cycle or an LH surge or ovulation like the oocyte. No, it just starts developing as soon as we enter puberty in general. Okay, now remember these granulosa cells, which are the cuboidal cells. These granulosa cells are very special and they're very important. Now, why? It's because at this point, when they become multi-layered and it becomes a secondary follicle, again, this is wrong, they start to express FSH receptors. Okay, so these granulosa cells have a bunch of FSH receptors. Okay, but at this point, they're still not responsive. What does this mean? Even if there's FSH present and there are receptors on the granulosa cells, nothing happens. No process is initiated, nothing is instigated, nothing is being produced because the cells are still non-responsive. Okay, but just keep in mind at this point in time, the granulosa cells start to develop FSH receptors for a later period of time to start being responsive. But at this point, they're still not responsive to any FSH, even if it's present around, which it is because this is happening during puberty. Now, further maturing of the follicle, what happens is these granulosa cells start to secrete paracrine cells or paracrine factors or just mediators. They're gonna instigate the formation of theca cells. Okay, so basically, yeah, here paracrine factors that are released from the granulosa cells, they induce the formation of thecal cells. Okay, so again, I just like to repeat to join everything together. We go from squamous to cuboidal. That means primordial to primary. Single layer to multi-layer means primary to secondary. Then they start to develop FSH receptors, but they're still non-responsive. Second thing, the granulosa cells are going to instigate the formation of theca cells, okay, which is this green part. The green part is the theca and the pink part is the granulosa. The thecal cells express LH receptors. So the granulosa cells, they have FSH receptors, while the theca cells, they have LH receptors. So this is an important differentiation to make. Now, when it reaches this point, which is it has now the theca layer, it has the granulosa layer, it has the FSH receptors, everything is present, we call this a mature secondary follicle. In other words, preantral, okay? So these terminologies are important because in MCQs, if you don't know the option, like which follicle it's referring to, or like, because different follicles, like they indicate different things, you know? Not to this detail, but just understanding the names and the terminology really helps eliminate confusion when you're solving the exam. Even if you don't really need to remember details, just understand terminologies. Because if you have an option that's talking about preantral follicle, then an option talking about the Graafian follicle, an option talking about a secondary follicle, you're gonna be very confused, you know? But if you have a firm grasp on what each follicle means and the terminology behind each one, it's going to be very easy to avoid choosing the wrong answer just because you didn't know what they're referring to. You know, that's why I'm just stressing on the terminology. So again, after you have a thecal layer and a granulosa layer and everything is there, also you have this sticky layer around the oocyte, which is in yellow. It's called the zona pellucida. It's like a jelly around the oocyte. Just keep that in mind as well. We call this now a mature secondary follicle, okay? It's fully matured. Another naming that you might see on exams a lot is preantral. Why do we call it preantral? Because it's the follicle that's right before the formation of antrum. The antrum is basically fluid-filled spaces, like in here, for example. Do you see these fluid-filled spaces? These are called this is basically antrum. Okay, so the secondary follicle over here, which is the one we're talking about, is preantral. It's the one right before the antrum formation begins. Okay, so that's why it's referred to as the preantral follicle. Okay, so this is basically what happens. So now okay, so there's a question. Why are the receptors not responsive? Okay, basically, that's a good question. I don't really know exactly why, but all I know is that, or all you need to know for now is that up until this point, these receptors are not functional or they're not working yet. Okay, so even if there's FSH around, and it can't really bind and instigate anything within the granulosa cell. Okay, so just keep that in mind. Why exactly? I don't know. Yeah, they're just growing. That's it. We hit puberty, they just start growing. Okay, it's not related to how much FSH is around. It's not related to any LH surge or FSH increase or decrease or the menstrual cycle or anything. No, it's independent of all of that. Okay, it's just growing in the background. Like this is continuously happening. Is that clear? Okay. So up until this point, which is when we reached the secondary follicle, so far we've discussed the blue part. Up until this point, this is, as we mentioned, independent of the gonadotropins. So it's independent of FSH, it's independent of LH. This is a very, very important concept. So it's gonadotropin independent, okay? So this process, just as soon as we hit puberty, okay, not here. This is not puberty, this is fetus. Wait, here. Okay, when we start the development of the follicles is puberty. So as soon as we go into puberty, the follicles start to develop. Okay, it's not because there's FSH, there's LH, no, it's just probably the pulsatile movement of the gonadotropin releasing hormone. So this is continuously happening in the background. Okay, it takes about 3 months. So like every day there's a bunch of them going into the cycle and they're growing and they're developing. Okay, so just keep that in mind that this blue part is independent of gonadotropins. I'm sorry I'm repeating this so much, it's just a very important concept. Now, to go from a secondary follicle to an antral follicle, we need FSH. Okay, so this is where it starts to respond to FSH. It starts to be dependent on FSH. It starts to need FSH to grow further. Okay, so with that in mind, we start the menstrual cycle. So when I explain the menstrual cycle, which is this graph over here, I'm starting with basically this part. Okay, this is where I'm starting with. Okay, so we're starting with a bunch of secondary follicles. Okay, so let's take that concept of secondary follicles and we can start understanding the cycle now. So I don't know why it's doing that. 1 second. Okay, that's better. Okay, so let's now try to piece this idea together. So when I say day 1 of the cycle, okay, because we're going to use this terminology a lot, first day of the cycle or day 1 of the cycle or beginning of the cycle, we're basically referring to day 1 of bleeding or day 1 of menses, okay? So the first day that the uterus wall sheds and it bleeds, that's what we refer to as day 1 of the cycle, which is over here, okay? So what happens day 1 of the cycle? FSH starts to increase, as you can see here. The reason FSH increases, you'll understand when we get to the end, okay, because it's a whole cycle. But for now, just follow with the idea that FSH increases in the beginning. Now, as we said, to go from a preantral follicle, which is the secondary follicle over here, to go from a secondary follicle to an antral follicle, we need FSH. So this aligns perfectly. Day 1, FSH increases. So because FSH increases, what is it going to do? It's going to recruit secondary preantral follicles to develop into tertiary antral follicles. Okay, so this is all that's happening in this first part. The rise in FSH is going to recruit like around 20 secondary follicles. Number is not accurate, but just remember that it's like it recruits multiple secondary follicles and it makes them develop into tertiary follicles or antral follicles. Okay, this process is FSH dependent. That's why it only happens in the beginning of the cycle when FSH goes up. Then, Is this part clear, the first part of the cycle? Okay, if you have any questions, please just interrupt in the chat. I don't mind. Okay, so now we have the tertiary follicles, okay? Or in other words, the antral follicles, okay? So we are basically here now, okay? The antral follicles. Now, these antral follicles, they have so many FSH receptors, and they're very, very, very highly dependent on FSH for growth and viability. Now, what does this mean? It means that these tertiary follicles or antral follicles, I'm going to refer to them as antral because this is the most used terminology. These antral follicles, the large ones, they were small, they became large over time with growth. The large antral follicles, they have many FSH receptors, and they're very dependent for viability, especially. What does that mean? When I say something is dependent on FSH for viability, it means that it needs it to survive, not just grow or speed up growth or make it mature. No, it needs it for survival. Okay, so keep that in mind. It's for growth and viability. Okay, now remember in the secondary follicle and the primary follicle and the primordial follicle, none of them were dependent on FSH. And the secondary follicle, it had FSH receptors, but they weren't responding to FSH. Now it's different. Now we have the tertiary follicle, which has the granulosa cell, and it has FSH receptor. These FSH receptors are very highly responsive to FSH, okay? So in the secondary follicle, it had receptors, but it did not respond to the presence of FSH. In the tertiaries, I'm just going to put the third follicle or the antral follicle, it has receptors for FSH and it's very highly responsive to the FSH, okay? So this increase in FSH that we see here, it's gonna affect or it's gonna bind to the granulosa cells and it's gonna cause the granulosa cells to produce estrogen. Okay, so that's the primary function of the granulosa cells. So again, we have I can draw it maybe here for you guys. You have the follicle, okay? These are the granulosa cells. Okay, if we can zoom in on one of them, it has FSH receptors. Okay, so they're very highly responsive to FSH. So when the FSH binds, because the FSH levels went up, as we said. Okay, so when the FSH binds, what's gonna happen is it's gonna cause the granulosa cell to produce estrogen and inhibin B specifically. Okay, now the role of inhibin B is just to regulate the production of FSH, like feedback on the pituitary gland. It's not that important. Just keep in mind that it causes feedback regulation on the pituitary gland so that we don't produce too much FSH. Okay, so now there's something contradictory happening. There's a problem. Why? Because we said that these large antral follicles, they need FSH to survive. Okay, and they're very responsive to FSH. But at the same time, they produce a lot of estrogen and inhibin. Estrogen and inhibin, they cause negative feedback on the pituitary gland. So this causes a decrease in FSH. But these follicles need FSH to survive. So what happens then? Basically, only one follicle survives and the rest all die out because the FSH went down. Okay, now again, what happened is we have a large antral follicle, which is very responsive and dependent on FSH. So when the FSH binds to these cells on the follicle, it causes the production of estrogen. Estrogen is going to cause feedback inhibition on the pituitary gland to decrease production of FSH. This is a problem because the follicles need FSH to survive. Okay, so what happens is the follicles start dying. Okay, they start dying because if you can see here, if you can see here, follow with the green, the FSH went up. Okay, so it binded to the granulosa cells, which started to make estrogen, which is the purple. That's why estrogen started to go up. Now, as estrogen went up, it caused feedback inhibition on the pituitary, and the FSH went back down. Okay, so is it starting to make a bit more sense, I hope? Okay, so now because the FSH went down, which is the green, these follicles start to die. Okay, because they need FSH for survival. Okay, so they start to die. Only one follicle ends up surviving. We call this the dominant Graafian follicle. Why did it survive? Because it was the follicle with the most amount of FSH receptors. Okay, so because it had the most amount of FSH receptors, it was the least hurt by the decrease in FSH levels. Okay, so this is the formation of the dominant Graafian follicle. Okay, so is this part clear for everyone? Okay, so, okay, that's great. Just one more time to connect everything together. We start off with secondary follicles. These secondary follicles need FSH to become tertiary follicles. So we have a surge, or not surge, we have a rise in FSH over here. This rise in FSH causes the growth or development from secondary follicle to tertiary follicle. Okay? Now, these tertiary follicles or antral follicles are very highly dependent on FSH, and they have many receptors that are responsive. So this FSH is going to cause the follicles to produce estrogen. So estrogen starts to go up. The rise in estrogen causes feedback inhibition on the pituitary to tell it, okay, listen, we have enough estrogen, stop making FSH. Or not stop, basically decrease. So FSH goes down. Now FSH went down, that's a problem. The follicles need FSH to survive, so they start dying out. So only one remains, which is the dominant one. Okay, so this is basically the concept. Is the dominant follicle the one that produces the most estrogen? Yes, it's the one that produces the most estrogen. So this is the surge over here. Yes, you're correct. So basically, up until this point is what we've talked about. Okay, FSH goes up, causes the production of estrogen. Because estrogen is going up, it causes feedback inhibition, and FSH goes back down. Now, as you mentioned, now we have the dominant follicle. The dominant follicle produces large amounts of estrogen. That's why we have a more sharp increase in estrogen over here. Because here the estrogen was just being produced by the antral follicles. Now, after FSH decreased, they died out. So now the production is from the dominant follicle, and the dominant follicle produces so much estrogen. That's why it becomes a steeper slope. Okay, so to answer your question, basically, yes. So is this part clear? So basically we are here. Is this part of the cycle clear? Okay, great. Now, this is just a graph that the doctor included. It's basically what we've talked about. It starts off with the follicles. This is to answer your question previously when you asked, why are they not responsive? Are they just growing? It's yes, they're just growing. The follicles enter and undergo early growth, and it's just regulated by paracrine factors. Okay, they're not really dependent on the pituitary gland. They're not really dependent on hormones. They're just growing. You know, they're just developing in the background, like constantly. So this allows the formation of the secondary follicle. Then this secondary follicle, it starts to have dependence. Okay, dependence starts, but it's still not that sensitive. Okay, but it is dependent. Then when we have the dominant one, it's extremely sensitive to FSH, and only one survives, okay? A decrease of FSH. So we start with not dependent on gonadotropes or gonadotropins, slightly dependent on gonadotropins, and then extremely sensitive to levels of gonadotropins. So when they go down, only one survives. Okay. So this is the dominant follicle. Okay. So this is the one that survived out of the rest. That's why with each cycle, we only ovulate one egg. Okay, only one gets ovulated, while the rest that tried to grow and compete with it, they die. So with every cycle, so many eggs die, but only one survives. That's why the egg count decreases tremendously with age in women. Okay, so only one survives. This is the dominant follicle. Okay, the only surviving follicle. Keep in mind, the egg inside or the oocyte inside is still a primary oocyte that's arrested at meiosis 1 prophase 1. Okay, so what we're talking about here is the development of the egg's house, let's say, the follicle. But the egg itself inside, like we mentioned, it's still in meiosis 1 or prophase 1. Okay, so the structure of a dominant follicle, basically, the granulosa cells, they start to like divide into two locations. You have the mural cells, which are the ones outside or like on the borders. These are the mural cells. And you have the cumulus cells, which form the corona radiata, which are basically the ones directly surrounding the oocyte. Okay, so mural cells, which are on the border, and the cumulus cells, which are around the oocyte. Okay, so this is, as you mentioned over here, the dominant follicle produces high amounts of estrogen. Okay, so this is the structure of the dominant follicle. As you can see from the structure, you can tell what's about to happen because it's pushing the egg to one side. It's like getting ready for the egg to burst out of the follicle. Not yet, but like this is what the structure is trying to do. So now we go from the dominant follicle into the LH surge. So as we said, the increase in estrogen over here, the purple line, is highly or mainly due to the production of estrogen by the dominant follicle. It's that the dominant follicle produces so much estrogen. That's why we have a sharp increase in estrogen. But what's really special about the menstrual cycle is that in the middle or during this period of time over here, which is around ovulation, instead of negative feedback happening, we actually have positive feedback. Okay, what does that mean? Didn't we mention before that a rise in estrogen should negatively feedback the pituitary gland to decrease LH and FSH? Well, if you see here, this kind of contradicts what we said. We have a rise in estrogen, but we also have a rise in LH. We have a rise in FSH. How are all of these things rising all together? This is called positive feedback. So what does positive feedback mean? It means an increase in the level of one hormone causes the increase of another hormone that caused it to increase in the first place. So it's just like a cycle that adds and adds and adds. Okay? So, for example, you turn on the AC, okay, and it gives you cold air. Okay, so instead of turning it's getting too cold. Instead of turning off the AC, you turn it even to a cooler temperature, you know? So that's kind of like what positive feedback, that was a terrible example, but like you get the point. So instead of negative feedback happening, which I mean, if you look at the cycle, you would technically, like if you want to use common sense, you'd be like, okay, since estrogen is going up, shouldn't LH go even more down or stay down or stuff? Why is it going up? It's because it's a special process or a special, let's say, what's the word? Exemption? I don't know. It's like special, okay? So it doesn't follow the rules. It's going positive feedback, not negative feedback. Now, this rise in estrogen causes an LH surge. This is the LH surge that we mentioned earlier. And if you remember, what did we talk about the LH surge? The LH surge is what took the primary oocyte from meiosis 1 into meiosis 2 to become secondary oocyte. Okay? So, Okay, yeah. So now we have the LH surge, okay? The LH surge, which happened as a result of positive feedback due to the upsurge of estrogen, causes many changes in the follicle or the egg and everything. One of the main changes is that it allows the oocyte to complete meiosis 1 and enter meiosis 2. Okay? Another thing that the LH surge does is that it causes structural changes within the follicle to allow the oocyte to rupture from the follicle. In other words, allowing ovulation to take place. Ovulation is just the oocyte leaving the follicle or being ovulated or exiting the ovary, So, first thing, it allows the primary oocyte to become a secondary oocyte. Second thing, the LH surge causes structural changes in the follicle to allow ovulation to happen. Third thing, it allows the biogenesis of the corpus luteum. Now, we're going to discuss the corpus luteum later, just keep that in the back of your mind. Is everything clear so far up until this point? Okay, cool. So, please, if you have any questions, feel free to interrupt. If you want me to repeat a slide or repeat it from the beginning, like whatever you want. So when it comes to meiosis 2, are you typing or so when it comes to meiosis 2, the secondary oocyte, yeah, what makes it complete meiosis 2? What makes it complete meiosis 2 is fertilization. So basically what happens is you have the primary oocyte, which is stuck in prophase 1 of meiosis 1, right? Then with the LH surge, which is this part, okay, it causes it to go into meiosis 2, or more specifically, metaphase 2, okay? Then it gets ovulated, okay? So, in other words, the LH surge leads to ovulation. When it gets ovulated or it leaves the ovaries, it's still stuck in metaphase 2, okay, or meiosis 2. It starts to look for a sperm to fertilize. If it fertilizes with a sperm, it completes meiosis 2, okay, and becomes a mature ovum. If it doesn't fertilize with a sperm, it just degenerates, okay? Okay, cool. So I hope everything is clear until ovulation. Okay. So as we said, the LH surge, which leads to ovulation, it causes the oocyte to complete meiosis 1 and enter meiosis 2. How does it do that exactly? This is the mechanism of it. So let's go into detail. So this isn't necessarily high yield, but I wanted to include it for the sake of completion because the doctor always mentions it every year. And you might get like a question, like maximum, but for the sake of completion. How does the LH surge remove the arrest on the oocyte? So basically, what causes the oocyte to remain arrested in meiosis 1 in the first place? It's basically high cyclic AMP levels. Okay, so high cyclic AMP levels within the oocyte make it arrested, or it makes it not leave meiosis 1. Okay, now this cyclic AMP is broken down by phosphodiesterase. So logically, if you want to add 1 plus 1 is 2, if we want the oocyte to remain in arrest, we need to maintain high levels of cyclic AMP. If we want high levels of cyclic AMP, we want to reduce phosphodiesterase because phosphodiesterase breaks down cyclic AMP. We don't want that. We want it to stay arrested. Okay, so who helps with that? Basically, the cumulus cells of your granulosa, which are these cells right here. Okay, what happens is these cumulus cells, I'm gonna draw them like this. Bear with me. And this is the oocyte. Okay, these cumulus cells are going to produce cyclic GMP, which is guanylyl. You get what I mean? Okay, so CGMP. Okay, so these cells over here, they're gonna produce CGMP, and the CGMP is gonna pass through the gap junctions to reach the oocyte. Okay, this CGMP inhibits phosphodiesterase. So now CAMP levels remain elevated inside the oocyte. Okay, this is before the LH surge. Okay, I'm basically explaining why is the oocyte arrested in meiosis 1 in the first place. So again, in order for it to be arrested in meiosis 1, we need very high CAMP levels inside the oocyte. If we want high CAMP levels, it means we need to decrease phosphodiesterase or inhibit phosphodiesterase. Why? Because phosphodiesterase breaks down cyclic AMP, but we want high levels of cyclic AMP. We don't want to break it down. So who helps with maintaining these high levels of cyclic AMP? It's the cumulus cells around the oocyte. These cumulus cells are going to secrete CGMP, which is going to seep through the gap junctions, enter the oocyte, and inhibit phosphodiesterase. This keeps CAMP elevated, okay? So CGMP from the cumulus granulosa inhibits the phosphodiesterase, keeping CAMP elevated, okay? So this is why the oocyte is arrested in meiosis 1 before the LH surge. Now, during the LH surge or after the LH surge, what happens is the LH closes the gap junctions between the cumulus cells. So instead of it looking like this, it doesn't look like that spaced apart. You get what I mean? It starts to look like this, very tight together, no gap junctions whatsoever. Okay, you get what I mean? And this is the oocyte. So even if these cumulus cells are still producing CGMP, they're not able to pass through the gap junctions to reach the oocyte. So now we can't inhibit phosphodiesterase. We're not able to because the CGMP is not reaching the oocyte. So now the phosphodiesterase, because it's not inhibited, it's allowed to degrade the CAMP. So CAMP levels go down and the arrest is removed from the oocyte. Is this concept clear? If I was too fast, please let me know. I'll repeat it and slow down a bit. Clear, okay, cool. So generally, if you really want me to slow down or repeat the entire thing, I really don't mind. I can stay here all day. Like, this is very important concepts, you know? So it's really important that you understand what's happening. Okay, so we explained now what's happening over here. So basically, the LH surge, this is LH surge, right? We stopped over here. What did it do? It caused the oocyte to go from meiosis 1 to meiosis 2. It caused structural changes within the follicle to allow the oocyte to ovulate or rupture from its follicle, which is what happens over here. Okay, so okay, now a really important concept to keep in mind, and this is like the target for many MCQ questions, is that before ovulation, which is the follicular phase, the hormone that dominates is estrogen. Why? Because we said the follicles, their granulosa cells become receptive to the FSH and they start to produce estrogen. So estrogen is produced by developing follicular cells. Okay. Post-ovulation, progesterone takes over. As you can see from the levels, before ovulation, the progesterone, which is the yellow line, it didn't even move. It doesn't, like there's no rise in progesterone before ovulation? It's mainly estrogen. Post-ovulation, yes, you do have a rise in estrogen, but progesterone is the hormone that's dominating. Its effects are the ones that are dominating. So post-ovulation, you have progesterone, which are produced by corpus luteum. We're going to talk about that. Pre-ovulation, you have estrogen, which is produced by developing follicles. So it's very important to keep in mind. Because just a tip for exams, especially for the repro part, the way the options came in the MCQ, you can easily eliminate options just by understanding what means what. Like you'll get options, for example, the developing follicles are secreting progesterone. Even though you might not know the answer to the question, but you know that the developing follicles don't produce progesterone. So you can just eliminate it based on the fact that you know they don't produce progesterone. Even though you don't really know which of the MCQs are or which of the options are the answer to the MCQ, just generally having an understanding of what means what helps you eliminate so many options. That's generally how I got through so many questions in the repro part, It's just understanding terminology is what happens when. So, and he does this on purpose, by the way, just to test your knowledge. So, anyways, so let's continue. So we said that the LH surge, we talked about how it affects meiosis, how it affects meiosis. Now we want to talk about how it affects the levels of the hormones. Why do we shift from estrogen production to progesterone production? Why is it that before the LH surge, we have estrogen dominating, but after the LH surge, we have progesterone dominating? Why does that happen after the LH surge? Basically, before the LH surge, we had the granulosa cells producing estrogen, as we mentioned. How does it do that? It basically works with the thecal cells. So this over here is a thecal cell, and this over here is a granulosa cell. Okay, basically what happens, thecal cells, they produce androgens or androstenedione. Okay, what happens is these androgens or androstenedione is carried to the granulosa cell and it's converted to estrogen, mainly by the enzyme aromatase. Okay, what produces or causes the expression of aromatase? It's FSH. Okay, so again, basically, we said that before ovulation, we have the follicles receptive and responsive to FSH. FSH induces aromatase expression. Okay, so basically, the thecal cell is going to produce androstenedione. This androstenedione is carried to the granulosa cell, where under the effect of aromatase, it's going to be converted to estrogen. So this is how the granulosa cell and theca cells produce estrogen. Okay, this all happens under the effect of FSH and LH. FSH mainly because it induces the formation of aromatase. Without aromatase, we can't convert these androgens into estrogen. Okay, so this is how it usually makes the estrogen. After the LH surge, there are many changes that happen to the structure of the granulosa cell. What happens? First thing that happens is that LH is going to inhibit aromatase expression, or the LH surge is going to inhibit aromatase expression. This already takes down the estrogen levels post-ovulation. Okay? Second thing that happens, it increases the expression of star protein. Star protein is needed for progesterone synthesis because it's a steroid hormone. Okay, so again, this explains why estrogen goes down after the LH surge. Okay, it starts to go down. Why? Because as soon as the egg ruptures or the oocyte leaves, there are changes that happen to the structure of the granulosa cells because of the LH surge. First thing that happens is the aromatase expression decreases. So now we have less estrogen being produced. Second thing that happens, we increase the formation of star protein. This increases production of progesterone. So this is why before the LH surge, it was mainly estrogen. After the LH surge, it's mainly now progesterone, and estrogen goes down. Okay, so is this part clear? Okay, great. If you need me to repeat anything at all, please just interrupt me. If you want to unmute or just send the chat, I don't mind. Okay, so okay, great. So now, just so we don't lose track of where we're going, everything that happened right now, everything we just described, all of these hormones, all these changes are part of the follicular phase. Okay, so why do we call it follicular phase? Very easy to remember. It's basically following the development of the follicles. Okay, so it's the follicular phase because what's causing these fluctuations in hormones and the estrogen going up and this going down and this going up? It's basically the follicles. They're the ones producing estrogen, which causes feedback inhibition and so on. So all of these hormonal changes and changes we see before ovulation are due to the follicles. That's why it's called the follicular phase. Okay, so we understood why estrogen goes down and progesterone starts to increase because of the changes from the LH surge. Now, why does LH go down? Because you might ask me, for example, if estrogen caused positive feedback here, okay, why doesn't it cause, for example, positive feedback later on? Why doesn't it cause another surge when it goes up here? Why is it when it decreases, this decreases with it? Or why is it when it decreases, it doesn't cause LH to increase because of negative feedback? You know? So basically, what you need to remember is the only place we have positive feedback is this place. The rise in estrogen because of the dominant follicle that causes an LH surge. Everything else is negative feedback. Great question. Is the proliferative phase the same as follicular phase? Okay, that's a good question. Don't worry. Basically, these terminologies are for the uterus, changes in the uterus. So this is the uterine cycle, which we're gonna discuss. These terminologies are for the ovarian cycle, but the proliferative phase and the follicular phase, they're occurring simultaneously. It's just in different places. Proliferative phase is happening in the uterus, and the follicular phase is happening in the ovaries. But yes, they're happening together in the same time. Okay, no problem. Okay, so all you need to remember again is that positive feedback only happens around the LH surge. Everything else starts to react normally. Okay, so after the LH surge, estrogen goes down because we said it switches to progesterone, and because estrogen goes down, this kind of ends the positive feedback. Okay, so positive feedback ends here. Okay, so estrogen dies out or it goes down. Now there's an end to the positive feedback. LH, the role of LH is done. Okay, it's tired, it wants to retire, it did the surge, it did everything good, it caused ovulation, it goes down, it's done. You know? So now after the oocyte ovulated, it's gonna leave behind the follicle, right? Because we had the follicle, the oocyte left, it ruptured. You have the remains of the follicle left behind because the oocyte ruptured, right? The remains of this oocyte develop into a structure called the corpus luteum. Okay, so why do we call it corpus luteum? Because it's basically, it happened due to the influence of the LH surge, which is the luteinizing hormone. So corpus luteum, this is why this is called the luteal phase. Okay, so basically the corpus luteum is nothing but the remains of the granulosa cells and the theca cells from the follicle after the oocyte already ruptured. It's basically just the remains. Okay, so let's take a deeper look into this corpus luteum because it plays a huge role in regulating progesterone levels. Okay, so the follicular granulosa cells and the theca cells form the corpus luteum. Now be careful, it's the mural granulosa cells, not the cumulus granulosa cells. The cumulus granulosa cells, they actually rupture with the oocyte. If you can see here, this part is the expanded cumulus. So the cumulus cells, which were the cells around the oocyte over here, they rupture with the oocyte. The mural cells, which are the ones on the border over here, and the thecal cells, these are the ones that form the corpus luteum. Okay, so now this corpus luteum, there are changes that happen to the granulosa cells. Basically, the granulosa cells, as we said, they shift their production into progesterone and producing cells. They also produce estrogen, but it's mainly progesterone. You can't completely eliminate estrogen, of course. That wouldn't be healthy, Aslan. We need estrogen. But progesterone is what dominates here. Okay? So the transient drop in estrogen after the LH stops feedback, the positive feedback. We talked about this. The fall in estrogen is what stops the positive feedback of LH. So everything goes down. Okay? So again, something to keep in mind, very important for the exam, pre-ovulation, it's the follicles that are producing estrogen. This is the dominating role. Post-ovulation, it's the corpus luteum producing progesterone. This is the dominating role. So high levels of progesterone means post-ovulation. High levels of estrogen is mainly pre-ovulation. Follicular cells is pre-ovulation. Corpus luteum, post-ovulation. Okay, so this is very important, differentiation to keep in mind. So now let's understand the second half of this cycle. We're almost done. Just hang in there. So now that we have the corpus luteum formation, okay, this corpus luteum, it forms progesterone, as we mentioned, but it also forms inhibin A. Now, do you remember where we saw the other inhibin? We have two types of inhibin. We have inhibin B, which is produced in the follicular phase, and we have inhibin A. They both have the same role. They both negatively feedback the pituitary. They try to regulate FSH levels. They regulate hormone levels. Very similar job. But the difference is inhibin B is produced by the granulosa cells in the follicular phase. Inhibin A is produced by the corpus luteum of the luteum. Inhibits. They just negatively feedback the pituitary gland. Okay, not that important. Just wanted to keep it in mind in case you see it in an option, you're not confused what's inhibin. So now for the most high yield part, this corpus luteum. Okay, it can't survive for that long. It has a specific survival duration. If you remember, type in the chat the duration of the luteal phase. How long is the luteal phase? Yes, it's 14 days. So why did we say the luteal phase does not change? It's always 14 days because the life duration of the corpus luteum is 14 days. The corpus luteum cannot survive beyond 14 days, okay? Because the LH surge is basically what formed the corpus luteum and it's what kept it going. That high amount of LH is what's is what kept the corpus luteum alive for 14 days. But after the LH goes down, you have a period of time where LH is not there. This period of time is 14 days, okay? So what happens or after it dies or it decays, okay? Basically, if the corpus luteum dies after 14 days, all of the hormones go down because the corpus luteum is producing progesterone in high levels, estrogen in low levels. It's producing our hormones. So after 14 days, it dies out or it degenerates into the corpus albicans, and the hormone levels go down. Okay, because it died. خلاص, the corpus luteum died because it can only stay alive for so long without the LH. Okay, so this brings us back to the beginning. Progesterone goes down, estrogen goes down. This sends back feedback to the pituitary and tells it to please increase FSH. This is where the FSH started. This is why it started to increase. Okay, so because the corpus luteum died in the end, so the estrogen progesterone went down, it sends feedback to the pituitary to increase FSH levels, and the cycle repeats. Now, there is an exception to when the corpus luteum survives. There's only one hormone, which is the human gonadotropin hormone, HCG. This hormone is the only hormone that can keep the corpus luteum alive beyond 14 days. And this hormone is only present when there's fertilization, so only in pregnancy. Okay, so if fertilization did occur from this oocyte that ruptured, it left the ovary, went to look for a sperm, blah, blah, blah. If fertilization did occur and embryo implantation did occur and pregnancy is there, HCG levels will be high in the body, or HCG hormone is going to be produced. Okay, if it is produced, it's going to be able to keep the corpus luteum alive. So if it keeps it alive, it means the progesterone and the estrogen won't go down. Okay, so if we prevent these hormones from going down, it means we prevent menses or bleeding. Okay, because what causes bleeding or the shedding of the uterine wall? Don't worry, we're going to discuss the uterine cycle now to understand it more. But what causes the bleeding or shedding of the endometrial wall? It's the fact that pregnancy did not occur. So why have a thick endometrial wall? Pregnancy did not occur. We don't need to support a fetus. We don't need to support an embryo. So let's just shed the lining, So this occurs only when estrogen and progesterone levels fall. Okay, so again, the corpus luteum, basically, what does it do? It produces progesterone and estrogen. It can only stay alive for 14 days without luteinizing hormone being there. Okay, so the only way it can stay alive beyond 14 days is the presence of HCG, which is only there during pregnancy. Okay, so because it's alive, progesterone and estrogen will not go down, they'll stay elevated. And if they're elevated, bleeding will not occur. That's why during pregnancy, there's no period, there's no menses, there's no bleeding, okay? Another way, or like vice versa, if there is no fertilization, no pregnancy, no embryo formation, nothing happened, no embryo implantation, HCG will not be present. So the corpus luteum, after 14 days, it just dies, okay, or it degenerates. So progesterone and estrogen levels go down, they fall. Estrogen, progesterone, they fall. This fall in estrogen and progesterone is what causes the bleeding. Okay, and it's what causes the increase in FSH to kickstart the cycle. Is this graph starting to make sense now? Okay, does anyone want me to like quickly go from point A to point C, like in one go? Or do you want me to just move on to the uterine cycle? Yes, to which part? You guys are saying yes, but I can't tell yes to which part. Mini summary. Okay. So let's go. I think I put a graph here. Okay. So now let's try to make sense of this entire graph. You need to, like, trust me, if you really understand this graph, all the questions are going to be super easy. Okay. In the end, I have 10 questions that I added, and they're very similar to exam questions. They're questions by the doctor himself that he gave us last year. So if you're able to solve them, inshallah, you're going to be good for the exam. But what I wanted to point out is by just understanding this graph, you're gonna have like when you close your eyes, you're gonna see it. Like you can see the graph in front of you. You know what I mean? Like you can remember, okay, follicles, follicular is here, luteal is here. Okay, we have more progesterone here. Okay, we have more estrogen here, you know? Like you can kind of imagine everything if you fully understand it. So that's why I'm spending a lot of time on this. Okay, so quick review. Where do we start? We started here. We said that as soon as we hit puberty, the follicles start to mature. Okay, so that's independent of FSH. We don't care there's FSH, no FSH. It's not dependent, it's not responsive, nothing. Okay, so we get to a point where we have secondary follicles or preantral. Okay, this is where we, like these secondary follicles, multiple of them, or like 20 of them, let's say, or a few of them, get recruited and they enter the menstrual cycle, or they enter the cycle that you are looking at right here. Okay, so we're starting with a bunch of secondary follicles. Okay, now because there's a fall in estrogen and progesterone here, because the corpus luteum died, it's going to send feedback to the pituitary to increase FSH. So this is why the FSH goes up. The role of FSH is to recruit secondary follicles and convert them or make them develop into tertiary follicles, or in other words, recruit preantral follicles and form antral follicles. Okay, so now that we've recruited a bunch of secondary follicles to form antral follicles. So 1 second, guys. Okay, so I'm sorry. So now that we have the secondary follicle, I'm sorry, guys, just 1 second. Okay, I apologize. So now we have the secondary follicles. The rise in FSH is going to recruit a bunch of secondary follicles and allow them to become antral follicles or tertiary follicles. These tertiary follicles or antral follicles have FSH receptors and they're very responsive to FSH and they're very dependent on FSH. What do we mean responsive? It means that the granulosa cells in the follicle start to produce estrogen in response to the FSH. So that's why estrogen starts to go up, because the follicles are producing, they're starting to produce estrogen. But now we have a problem. These follicles, they need FSH to survive, but at the same time, the presence of FSH makes them produce estrogen. So the rise in estrogen induces negative feedback on the pituitary gland to decrease FSH. Okay, so it's very contradictory. They need FSH to survive, but they're producing estrogen. Estrogen is causing a decrease in FSH. So FSH falls again. Now, we said that they needed to survive. So what's going to happen is they're all going to start dying out, except for the dominant follicle, which is the one with the most FSH receptors. It survives. This dominant follicle produces a lot of estrogen. That's why we have a steep increase in estrogen, because the dominant follicle is producing a lot of estrogen. Okay, so until this point, we have feedback inhibition. After this point, we have positive feedback. This rise in estrogen actually causes positive feedback, which causes a rise in LH, or the LH surge. What are the effects of the LH surge? Basically, it causes the oocyte to go from meiosis 1 into meiosis 2, and it shifts the production from the granulosa cells from estrogen to progesterone, or not completely shifts, but it decreases estrogen production, increases progesterone production. It changes the focus, okay? And most important thing, it changes the structure of the follicle, allowing the rupture of the oocyte, okay? Now, after these things happen, the levels are going to go down, because we said the changes allow it to shift from estrogen to progesterone, the LH goes down, everything goes down. Now, the remains of the follicle produce the corpus luteum. Okay, sorry, corpus callosum is something in neuro. We'll take it later, so I keep confusing this too. So the follicle, after the oocyte ruptures, the remains of it produce the corpus luteum. Okay, the corpus luteum is mainly like specialized in producing progesterone, produce a lot of progesterone. It does produce estrogen, yes, but not as much as progesterone. Its main focus is producing progesterone. That's why the progesterone levels go up. Okay? Now, this corpus luteum can only stay alive for 14 days if there's no embryo implantation, no fertilization, no presence of the HCG. It can only stay alive for 14 days. After 14 days, it dies. So now there's no estrogen and progesterone production. Okay, they go down. This causes the FSH to go up again. So, does anyone have any question regarding this part? Is it clear? Are you guys sure? I want you to be 100% sure. Okay. Inshallah, it's clear. Okay, any questions? Is there anything at all, any slide you want me to go back to, anything you want me to review or go into more details or okay, I hope inshallah everything is clear so far. So this is like the last part. So it's very, very simple compared to the ovary, very simple. So the uterine cycle is split into three parts. Menstruation, which is the bleeding or the shedding of the endometrial lining. Proliferative phase, which is from the name, proliferation of the wall happens, because after it sheds and bleeds, we need to rebuild the wall. So in case next month we have embryo being implanted, you know. Then we have a secretory phase, which is dependent on secretions. So you're gonna have a lot of secretions happening, no proliferation. Okay, so now that we understand the fluctuations of these hormones, okay, now, for example, if I get you in the exam and this isn't labeled, just by understanding that progesterone dominates in the luteal phase, you'll understand that this line presents progesterone. You know, just by understanding that it's mainly estrogen that dominates in the follicular phase, you're gonna know that this is for the estrogen. You know, so just having a general understanding really makes questions very easy to solve. Okay, so let's start. So this graph is a bit better. So I think to keep in mind, menstruation and proliferative phase are before ovulation. So they're basically happening the same time as the follicular phase. Okay? The secretory phase is after ovulation and it's mainly happening with the luteal phase. So just by your common understanding, what do you think, which hormone, estrogen or progesterone, is the one that's causing proliferation? Exactly, estrogen, because we mentioned that estrogen is the hormone that's dominating in the follicular phase. So by just knowing that, the uterine cycle becomes so easy to understand. You'll know that the main hormone responsible for the proliferation of the endometrium is estrogen. Which hormone is responsible for the secretions? Exactly, progesterone, because it's happening after ovulation where progesterone levels are the highest. So this is in general what happens in the uterus. And as we said, the bleeding is due to the fall in the estrogen and progesterone because of the corpus luteum dying. So you have bleeding because there's nothing to support the endometrium wall. So it just bleeds. The effect of estrogen starts here. And over here we have the effects of progesterone. Okay? So now, to understand what happens, very simple. Basically, this is the endometrium, this part over here. There's the functional zone and there's the basal zone. The functional zone is the part that that sheds off during menses or during bleeding, not the basal zone. This can come as an MCQ. I've seen it before. Which part is the one that sheds during the menses or menstruation or bleeding? It's only the functional zone. So this part is the part that sheds off or bleeds or sloughs of the endometrium during the menses period. Okay, it's the functional zone. the basal zone stays there and it rebuilds the functional zone above it for the next cycle. Okay, so also just having this general understanding can help you eliminate choices, because you'll see many choices that are like um, uh, the bleeding or the shedding of the basal zone of like, so you can immediately just cross the option out, you know? So one more concept too that's important is that a branch of the uterine artery we have, it's called a spiral artery. This is the main artery that's supplying the functional zone. Okay, so that's it. Now let's talk about these. Very, very simple. Menstruation, which is the first part. Back to the graph we're all used to. This is menstruation, the menstrual phase. Why does it happen? Because of low levels of estrogen and progesterone. Okay, so the functional layer is shed during days 1 to 5 due to a fall in estrogen and progesterone. Very easy, done with the menstrual phase. For the proliferative phase, estrogen that's formed from the dominant follicle induces the cells to proliferate. Okay, so remember in this phase, we have the dominant follicle that was chosen and it was producing a lot of estrogen. So this rise in estrogen or dominance of estrogen pre-ovulation is what's causing the proliferation of the basically these layers. Okay. So what does estrogen also do? It induces the expression of progesterone receptors. So basically, the endometrium is responsive to estrogen. Okay. But in the secretory phase, we need the endometrium to be responsive to progesterone, but it doesn't have progesterone receptors yet. So estrogen in this phase prepares the endometrium by inducing it to have progesterone receptors, so that when the endometrium enters the secretory phase, it's able to respond to progesterone. Okay, so again, basically in the proliferative phase, we have the effects of estrogen that's being produced by the dominant follicle. What is the estrogen doing? It's basically causing proliferation of the endometrial lining, proliferation of all the cell types. Everything is just proliferating. We're trying to create a really thick endometrial lining to support an embryo. Okay, so this is the role of estrogen. So before the endometrium enters the secretory phase, the estrogen has one more job. It goes like, okay, I need to make sure that the endometrium is able to respond to progesterone when it enters the secretory phase. So what do? It induces the expression of progesterone receptors. Okay, so that when it enters the secretory phase, it's able to respond to these high levels of progesterone. Okay, so then what happens? We have the secretory phase. In the secretory phase, we have the progesterone, which is basically after ovulation. Okay, we have high levels of progesterone. Where are they coming from? From the corpus luteum, as we mentioned. Okay, this presence of progesterone switches the proliferative phase into the secretory phase. Okay, so what does the progesterone do? It inhibits endometrial growth. So proliferation stops when we stop with the proliferative phase. Okay, because levels of progesterone inhibit endometrial growth. All the progesterone does is it induces the glands to secrete like a nutrient-rich product, because it's preparing for embryo. You know, it's preparing to nourish an embryo. It's preparing to support an embryo. So it starts to do all or to produce all of these secretions. Hence the name secretory phase. Okay, and a really important thing that you'll notice is that the glands become corkscrewed, so they become very convoluted, the glands, and the spiral arteries become very prominent. Okay, so this is very important, and that's basically it for the uterine cycle. Okay, so before ovulation, it's mainly proliferation, okay, because of estrogen from the dominant follicle. After ovulation, there's no proliferation, no growth, because progesterone inhibits growth. All that's happening is secretions, carbohydrate-rich secretions, nutrient-rich secretions. The glands start to become very convoluted. The spiral artery is very prominent. All of these things happen, but there's no growth. So just follow the name. Proliferative phase is proliferation. Secretory phase is mainly secretions. So all of this is happening at the same time as everything else we've discussed. Okay, so This is just a picture that you'll definitely see on the exam. Which one is in the proliferative phase and which one is in the secretory phase. We got this in the OSPE, I remember, but it was a more like histologically picture, like it was clearer than this one. They got us two pictures and they're like, which of one is represents the endometrium during the secretory phase, you know? So you need to look at the difference. Look at the glands. They're very convoluted and corkscrewed. Okay. So this is a very big giveaway. So does anyone have any questions? We're done with the menstrual cycle. Oh, there's a question in the chat. If the ovum was fertilized, does the secretory phase induce its attachment to the endometrium? Yes. It's actually a point I put here I forgot to talk about. Because it's not, you mainly talk about pregnancy and stuff in other lectures, but over here, progesterone basically, it induces changes in the adhesivity of the surface. So basically, it makes the walls very adhesive, very like sticky, a very welcoming environment for an embryo. Because in case it implants, it basically makes the implantation of the embryo very easy because it's like adhesive now. That's also the role of progesterone. Does that answer your question? Okay, no problem. Does anyone have any questions? Anything you want me to repeat regarding the menstrual cycle, ovarian cycle, uterine cycle, oogenesis, folliculogenesis? If you want to go through the cycle one more time. Okay, I hope it's clear. Please feel free to ask genuinely, I don't mind. But this is basically everything we talked about. Okay, you can see how everything overlaps with the uterine wall, with the eggs, everything overlaps together. So, okay. Inshallah, it's clear for everyone. So now for the last two slides, basically, the doctor mentioned many disorders, but only two of them I feel are genuinely high yield and they're asked about. So they're basically Turner syndrome and PCOS. So Turner syndrome is primary ovarian insufficiency. What does primary ovarian insufficiency mean? It means that the problem is not with the hypothalamus, it's not with the pituitary gland, it's not related to the GnRH secretions or FSH or LH. It's not really related to the hypothalamic pituitary axis. The problem is within the ovary itself. That's why it's called primary ovarian insufficiency. When something is called primary insufficiency, it means the problem is coming from this gland or from this organ or from the structure itself. It's not a secondary problem because of another problem happening somewhere else. Had this been a problem with the hypothalamic pituitary axis, it would have been secondary ovarian insufficiency, which means that there's a problem in the ovary due to a problem happening somewhere else. But because the problem is within the ovary itself, it's called primary ovarian insufficiency. So this is Turner syndrome. Now, because the ovary is not functioning well, we have this estrogen and progesterone insufficiency. Okay, because you know that the granulosa cells, the follicles, all of these are the structures needed to sorry for that. So basically, estrogen and progesterone, they're not being synthesized properly by the ovaries, from the follicular cells, from the granulosa cells, from all the structures in the ovaries themselves. They're not being able to synthesize estrogen and progesterone. So you have low levels of estrogen and progesterone. Okay. The main reason for this is basically they have a missing X chromosome. Because, females have an XX chromosome, but basically this one is missing. So they actually have an XO karyotype. So this is the hallmark of Turner syndrome. So what's important about syndromes isn't naming them necessarily, it's mainly recognizing them. So how do they ask questions in the exams? It's basically they will give you a scenario with these characteristics in them, and they'll tell you which of the following is most likely the cause or the diagnosis. The option will not be Turner syndrome. The option would be insufficient estrogen progesterone or ovarian insufficiency or blah, blah, blah. You know, like he's going to give you a scenario describing these traits, and the options will be mechanisms to why it went wrong. You know, he's not gonna, like, you don't really need to know the like names specifically, but keep them in mind because they might come. Okay, so because there's no estrogen and progesterone, puberty is going to be delayed, obviously. Amenorrhea, which means no period. Okay, obviously, again, because the hormones aren't regulated. How will they look? They'll have a short stature, a webbed neck, as you can see here. This is very characteristic. Low set ears and a shield-shaped chest. This is a very important giveaway. The internal and external genitalia are female. Okay, there's no ambiguous genitalia or anything like that. They're both internal and external, they're female. And this can be a hint in the exam because usually people with Turner syndrome, they have cardiovascular issues as well. So when you see that, that can also hint towards Turner syndrome. Okay, so all this is primary ovarian insufficiency. So you don't have estrogen and progesterone, so everything's like going on. Last slide, we have this polycystic ovarian syndrome. This is very important. It came in our exam last year as an MCQ. Basically, this, like, we don't exactly know the mechanism behind PCOS, but the most important thing to keep in mind is that it's due to hyperinsulinemia. Okay, so basically you have, it's highly associated with obesity. So when you have obesity, you have a high number of adipose cells. Adipose cells reduce insulin sensitivity. So now the patient has insulin insensitivity and they have hyperinsulinemia. Okay, the high levels of insulin promote androgen production by the ovaries, not by the peripheral tissues, by the ovaries. So because they're obese, they have insulin insensitivity, they have high levels of insulin or hyperinsulinemia. High levels of insulin increase androgen production by the ovaries. This is important, by the ovaries. So this leads to basically excessive acne, excessive hair on the face, on the back, on the chest, basically places a woman would not have excessive hair growth. Okay. Another feature is amenorrhea, which is a lack of period because you have a lot of androgens being produced. And another finding you'll find in a clinical scenario is the polycystic ovaries. So they'll give you a patient who's obese, they have polycystic ovaries that are detected by ultrasound. She has irregular hair growth in different places of the body. What's the most likely cause? Okay, they're not going to ask you, is it Turner syndrome or is it PCOS or is it that or is it 100? No, they're going to ask you what's most likely the cause. The most likely cause would be the hyperinsulinemia. That's because high levels of insulin increase androgen production. Okay, that's where all the symptoms come from. So just a note here, reduction in insulin levels actually improves the symptoms. That's a even higher indicator that it is the hyperinsulinemia that's causing this. So moving on to questions. Do you guys want me to wait for you to type the answer in the chat, or do you want me to just explain the answer right away? Okay. Let me just... One second, sorry. D. Okay. Does anyone have any other answer? Okay, you're correct. It is D. Now, basically, let's read the question. 7 days after ovulation. So right away, where are we? We're in the luteal phase because it's after ovulation. This is how, like, I'm gonna think out loud and maybe this will help with the بس عم أعطي حصة بس شوي تمام بس Okay, 1 second, guys. Can you please pause the recording? Okay, so I'm just gonna think out loud with the question and show you how you can eliminate options or process questions just by reading it in the exam. Inshallah, it will be helpful. So when you see 7 days after ovulation, this should hit you that this is the luteal phase. Okay, so pituitary secretion of LH decreases rapidly. What is the cause of this decrease in secretion? Okay, so let's start. The anterior pituitary gland becomes unresponsive to the effect of GnRH. We did not talk about anything regarding this, so we can cross this out. Developing follicles. Do we have developing follicles in the luteal phase? No. So without even knowing if this makes sense or no, you can immediately cross this out. Okay? The rise in body temperature inhibits hypothalamic release of GnRH. Did we talk about anything related to this? Not really. So you can cross this out. Secretion of estrogen and progesterone by the corpus luteum suppresses hypothalamic secretion and pituitary secretion. This is exactly what we explained. The biggest giveaway should be that because we're in the luteal phase, you should think of the corpus luteum being present. And what's the job of the corpus luteum? It's to produce estrogen and progesterone, mainly progesterone. And we said that the estrogen and progesterone, they're gonna induce feedback inhibition to reduce the pituitary hormones and everything else by feedback inhibition. Is this question clear before I move on to the second one? Okay. Okay, great. So yeah, this is the explanation basically. Luteal phase, corpus luteum. Okay. Now, question number 2. A young woman is given daily injections of a substance beginning on the 16th day of her menstrual cycle and continuing for 3 weeks. If the injections continue, she does not menstruate. The substance could be which of the following? Okay, someone said E. Do you guys have any other answers? Okay, that is correct. It is E. Now, why is it E? Because we said that the reason menstruation happens, in other words, bleeding of the uterus or shedding of the endometrial lining, is because of low levels of estrogen and progesterone, because the corpus luteum died. So if we're able to keep the corpus luteum alive, it will keep on producing progesterone and estrogen. So by not allowing the progesterone and estrogen to fall down, we're gonna we're gonna prevent menses or the bleeding of the menstrual cycle. So as we said here, if we administer HCG, the corpus luteum will survive. If it survives, progesterone and estrogen will stay up. This means that the uterine endometrial wall will not shed, basically mimicking pregnancy. Okay, because keep in mind, low progesterone and estrogen is why bleeding happens here. Okay, is this question clear? Does anyone want me to repeat this question? Okay, I hope it's all clear. So, third question, a patient with a 29-day menstrual cycle probably ovulated on which of the following days? Okay, someone said B, someone said C. The answer is actually C. Now, why? Because we said that a menstrual cycle length The duration can vary, but the only thing that's exactly, the luteal phase is 14 days. So the luteal phase is here. Okay, so the luteal phase is 14 days. And the whole cycle is 29 days. So if you subtract 29 minus 14, you'll get the exact day where she ovulated. Do you get what I mean? Yes, exactly. So 29 minus 14 is 15. Okay, so that's why. So patient is I drew it here, exactly. So this is the length of the cycle. Okay, here it's 28, in the question it's 29. Okay, and this part is 14 days. So if you remove this part by doing 29 minus 14, you're left over with the day of ovulation. Okay? Now, in the take-home ovulation kit, which set of hormones will be the best indicator that ovulation has occurred? Okay, someone said E. Someone else said E. Why do you guys think it's E? If a woman has, if you do a like an ovulation kit, or you just test the level of hormones, and she has FSH and LH, does that mean that she has definitely ovulated? If she has like, yeah, it's not E. Okay, someone said B. Yes, it is B. So why is it B? Estradiol basically is estrogen, don't get confused. So now, FSH and LH, if they're high, it doesn't necessarily mean that ovulation has occurred, because we need an LH surge and we need high estrogen levels. Remember, high estrogen causes high LH, which causes ovulation. So if you do a sampling kit and you find high levels of LH and estrogen, it means ovulation has definitely occurred. Okay, so that's why we go with this. Now, you might wonder, why don't we go with C? Because many people argued with this, but basically, why did people argue for this answer? Because they were like, okay, if HCG is positive, it means the person is pregnant. In order for pregnancy to occur, it means she definitely ovulated. Well, this logic does make sense, but we can't use it as a confirmation. Why? Because if the HCG was negative, we can't say that, oh, because HCG is negative, it means the woman did not ovulate. No. If it's positive, it means she did ovulate, yes. But if it's negative, it cannot indicate whether she ovulated or not. You know, that's why it's not really the answer, because the hormones that we're using in this kit should be confirmatory, which means if they're present, ovulation did happen. If they're absent, ovulation did not happen. You know, it can't just be one or the other. HCG is used for pregnancy kits, not ovulation kits, because if it's not present, we can't rule out the ovulation happened or not. Okay, so next question. As menstruation ends, estrogen levels in the blood rise rapidly. Which of the following is the source of estrogen? Okay, I'll give you a hint. Menstruation is bleeding. As bleeding ends means we're around day 5 to day 7. So we're still beginning of the menstrual cycle. Someone said A. We're in the beginning of the menstrual cycle, so be careful.
I say B.
Okay. No, I'm joking, E. It's not E either. Okay, yes, it is B, but can you tell me why you thought it's E?
Because at day 7, the follicles already must secrete estrogen.
Exactly, it is B. But I mean, like, the person who thought it's E. Why did you think it's E? because FSH increases. Okay, so I'll show you where you went wrong here. This is where FSH increases. Okay, we're talking about when bleeding ends. They said estrogen rises rapidly. What's causing this rise in estrogen? It's the follicles, remember? So basically, as menstruation ends, so we're talking about this period over here, okay? Why is estrogen increasing? That's what the question is asking. Why is estrogen increasing after the menstruation ends? As we said, it's because of the follicles, okay? FSH is only high here. FSH only recruits follicles in the beginning, which is during menses, okay? So this is why it's B. Is it clear why it's B and not E? Okay, cool. Question 6. By the way, these are all Dr. AG questions, so you might see them on the exam. So yeah, just like heads up. A 20-year-old woman is not having her menstrual cycle. Her plasma progesterone is found to be very low. What's the explanation for the low progesterone levels? Don't overthink questions. Just answer with what you know. You know, because generally the MCQs, I remember people did, like the people who didn't do well were people who overthought the answers. You just need to look at what you know and choose that. You know what I mean? That's how it works. Okay, someone said D. Does anyone else want to answer? Okay, yeah, it is D. So why is it D? Basically, a way to tackle questions like this. She's not having her menstrual cycle, so she's either not ovulating, or the corpus luteum is not like it's not working properly, because if the corpus luteum is not producing hormones at the rate it should be, then bleeding won't happen, you know, because we need a regular up and down motion of hormones for bleeding to occur or the menstrual cycle to be steady. Okay, so a way to tackle this question is just look at things you do know. What do you know? We know that progesterone is mainly produced by the corpus luteum, okay, and the progesterone is very low. It means, okay, probably there's a problem with the corpus luteum. So what does corpus luteal insufficiency mean? It basically means that the follicle to begin with was a very weak, not well developed follicle in the first place. So when it became a corpus luteum, it was very insufficient, very not like, it wasn't the most efficient in producing hormones because it was a bad follicle to begin with. You know, this is basically what it means. So always when you're looking at repro questions, look at things you do know. Let's say, for example, you don't know why she's not having a menstrual cycle, and you don't know what the reasons are for not having a menstrual cycle. So okay, ignore that. But you do know that progesterone is produced by the corpus luteum. So it makes sense if they're low, then that means there's insufficiency in the corpus luteum. So always go with what you know, okay? So next question. In a young boy diagnosed with precocious puberty, puberty can be best delayed by the administration of a long-lasting preparation of which of the following. Okay, just a reminder, agonist means it has the same action. Antagonist means it opposes the action of the hormone. This is a tricky question, but you can try. Okay, someone said B. Does someone else want to answer? Or do I say the answer? Okay, it's not B, it's actually C. Now, why is it C? Remember when we said that in order for puberty to happen, we need a pulsatile movement or secretion of GnRH. So if we give him an injection of a long-lasting preparation, if we just administer him with a steady level of GnRH, or we give him, for example, a fixed amount of GnRH, okay, a long-lasting preparation, then it means we're preventing puberty from happening, okay? So they said puberty can be best delayed, okay? So by giving GnRH agonists, which means same action as GnRH, in such a manner, we're preventing puberty from happening, because in order for puberty to happen, we need the GnRH to be given in a pulsatile manner. And that's not what they said. They said they're going to administer a long-lasting preparation, which means they're just going to give them a one-time injection of a certain hormone. So that actually delays puberty because we need it to be pulsatile. Is this concept clear? It's a very easy concept, but the way it's phrased kind of is annoying, you know? So I get it. Okay, that's good. So almost done. A key factor in the selection of the dominant follicle is high expression of which receptors? Okay, someone said A. A, exactly, yes, it's A. Okay, awesome. By the way, this looks really easy, but you will see questions like this in the exam. Like there are very there are many questions that just test your general understanding, you know? So because you understand the cycle, these are just easy marks, you know, instead of having to memorize all of this. Okay, withdrawal of which of the following hormones results in menstruation? This is a very tricky one. Okay, someone said D, someone else said D. Yes, it is D. So basically, we said that in order for menstruation to happen, it only happens if the corpus luteum dies and the progesterone and estrogen levels go down, right? Now, why didn't we go with estrogen? Basically, it's because progesterone is the dominant, if you can see in the graph, progesterone is the dominant hormone here. So because it's the dominant hormone, its decline is going to have the most prominent or potent effect, you know? That's why progesterone is a more suitable answer. Does everyone agree? Or do you have any questions? This is the last question. No, actually, we have two more questions. See, questions with graphs, you're gonna see so many of these on the exam. So again, just focus on things you do know. Just look at like keywords and choose your answer accordingly. You don't even have to read the entire scenario to know. Okay. So everyone is saying D. Yes, it is D. So how did you know it's D? What was like a key word or a key phrase or anything that led you? Exactly. So basically, we're talking about glands that are filled with carbohydrate-rich mucus. We're talking about secretions. We're talking about the supracoiled arteries and glands and secretions. We're not talking about proliferation or division or like which is a proliferative phase. This is very obviously the secretory phase, okay, because it's all about secretions. So at which point is the secretory phase most prominent? Basically D. Why didn't we go with C? This is exactly ovulation. Why didn't we go with E? This is when menses occurs, which is when the hormones are low. Okay, so basically, because progesterone is very high, the role of progesterone is the secretions and the glands and the arteries, all of that. That's the role of progesterone. That's why we went with D. Okay, if they give you a scenario where it shows high levels of proliferation of the basal layer and functional layer and stuff, you would go with B. Okay, with no, you would go with the. This isn't really clear. There is no estrogen on the graph in the first place, but you know what I mean. So this is what we go with. Okay, this graph is LH and progesterone, not estrogen and progesterone. Okay, so read the graph carefully, not like I did. So yeah, because progesterone is the reason we have the glands and everything, so we chose to, okay? So yeah, this is basically what we're talking about. Okay, last question. Yes, it's B. So basically, they're just describing PCOS to you, and we said that PCOS is basically uh, due to hyperinsulinemia because the high insulin levels they increase androgen production, which is why you have a lot of hair growth and acne and stuff like that. Why is it not elevated FSH? That's not the reason for it. Elevated estrogen production? Obviously not. Peripheral conversion of estrogen to androgens? That's not true because actually what's happening is that there's more androgen production in the ovaries, okay, which is very weird. So the answer is hyperinsulinemia, okay? Okay, does anyone have any questions at all? Is there anything you guys want to go over or you're welcome. I hope this was clear. Wallah, if you have any questions at all, please send me on email or phone number, text me. I'll gladly simplify or explain any slide you have doubts on. So this one last thing, if you can just scan the QR code for any feedback, anything you didn't like about the session, anything you did like, anything I can improve. So thank you guys so much for attending. You're welcome. Inshallah, this helped. Please attend LGDs because that's basically your exam. And one more thing, for SAQs, focus on the male sexual disorders because they're gonna come a lot in the SAQ. So inshallah, this is gonna be an easy A for you guys. It's a very easy block. Just understand and go with what you know. Don't overthink options about things you've never heard of, you know. So thank you guys so much. And if you have any questions, just let me know.